Now we have this integral from 0 to 1 of this function. Now it looks like a hard one. It's very difficult to go back to find the function here. So let's see what are we going to do in this case. So we have an integral from 0 to 1, 2x plus 1 times cos hyperbolic x squared plus x plus 1 dx. Let's pay attention to this parenthesis here. So what happens if I differentiate this quantity inside the parenthesis? If I differentiate x squared plus x plus 1 with respect to x, I get the 2x plus 1 here. So a good idea is to make this substitution. U is x squared plus x plus 1. Now the other step is to change the limits of integration. So for x equals 0, u equals 1. And for x equals 1, u equals 3. We can also change the differential. So du dx is 2x plus 1. So du is 2x plus 1 dx. So this is the integral. For x equals 0, the bound of integration is 1. And for x equals 1, the bound of integration is 3. We have cos hyperbolic of u times du is 2x plus 1 dx. 2 times x plus 1 dx, so this is du. Wow, this is a much simpler integral to compute. So we have the integral of cos hyperbolic, which this is sine hyperbolic of u. So we have sine hyperbolic of 3 minus sine hyperbolic of 1. So my integral I is sine hyperbolic of 3 minus sine hyperbolic of 1. So in the first instance, this integral looks a bit complicated. But if you pay attention and by making the right substitution, then everything becomes a very simple case to deal with. You change the variable, which is u now, and u is this expression here, this polynomial. You change the bounds of integration, you change the differential, and finally you obtain this integral, which is a very, very simple integral to compute. So you compute this integral of cos, so we know that if we differentiate sine hyperbolic, we get the cos hyperbolic, and so we have the function evaluated at the end point and minus the function evaluated at the first, at the left end point. So we have this expression here, and finally my integral is computed. Usually substitution helps a lot to simplify things, but you can compute this integral alternatively by not having to do this kind of substitution. I hope that you have enjoyed this video as much as I have enjoyed this video, and until the next time, I hope you are having a splendid and productive time with your families and whatever endeavors you are choosing to do.